Hi, in this video you'll learn how to prove trigonometric identities. So first off, in order to prove a trigonometric identity, we have to show that the left side of an equation is equal to the right side. And in doing so, we have to treat each both the left side and the right side independently of the other. So to prove identities, we can use the basic identities that the basic trigonometric identities that we already know. So far we know the Pythagorean identity, which is that sine squared theta plus cos squared theta is equal to 1. We also know the quotient identity, which is that sine theta over cos theta is equal to tangent of theta. And we know the reciprocal identities, that is that 1 over sine theta is equal to the secant of, the cosecant of theta. We know that the 1 over cos theta is equal to the secant of theta, and the cotan of theta is equal to 1 over tan theta. Now, because cotan of theta is equal to 1 over tan theta, cotan of theta is also equal to cos theta over sine theta. So cotan of theta is equal to cosine theta over sine theta. Now, we can use all of these identities to try to show that the left side is equal to the right side in this equation. So what we do here is we break up this equation into the left side and the right side. So I'm going to rewrite the left side is equal to the cotan of theta times the sine of theta. The right side is equal to the cosine of theta. Now, I'm going to try to what I'm going to try to do is, using these identities that I've written up here, I'm going to try to show that the left side is equal to cosine of theta, which would mean that the left side would be equivalent to the right side. When I go to do this, the best strategy to take is to try to make the more complicated side, to try to simplify it and make it equal to the side that's written in the simplest form. So normally, if you have something written like cotan or tangent, a good strategy to use is to try to convert it and write it in terms of cosine and sine theta, because here I can see that the right side is cosine theta. So I'm gonna replace cotan of theta with cos theta over sine theta. So I know that cotan theta is cos theta over sine theta times sine theta. Now, I have a factor of sine theta both in the numerator and the denominator, so those divide out, and I'm just left with cosine theta. So I've shown here that using the quotient identity, that the left side is equivalent to the right side, and thus I have proven this identity. So therefore, the left side is equal to the right side. Now, another important thing to note is that if theta was equal to 90 degrees, I would have that the left side would be equal to in this equation, I would have that the cotan of theta is actually undefined for theta being equal to 90 degrees. But the right side is just 0. So this identity only holds when theta is not equal to 90 degrees. So this is actually a restriction. This identity only holds when theta is not equal to 90 degrees. Now, in this course, we're going to not worry too much about restrictions, and we're just going to get the basics of proving identities algebraically. But you should know that there are certain conditions on the angle where this identity actually does not hold. You'll deal with more with restrictions on identities when you prove when you do further proofs of trigonometric identities in grade 12. So for now, we're just going to prove the identities algebraically. We're going to show that the left side is equal to the right side and not worry about the conditions of theta where the left side is not equal to the right side. Okay, so next we have another identity, and we've got cos squared theta minus sine squared theta is equal to 1 minus 2 sine squared theta. So again, we're going to break this up into the left side of this equation. So we've got the left side is equal to cos squared theta minus sine squared theta. The right side is 1 minus 2 sine squared theta. Now, anytime you have something like cos squared theta or sine squared theta, it's a good idea to try to use the Pythagorean identity. And just kind of as an aside thing, if we know that sine squared theta plus cos squared theta is equal to 1, well, I know if I subtract sine squared theta from both sides of the equation, I get that cos squared theta is equal to 1 minus sine squared theta. So I can actually replace, in this equation, I can replace cos squared theta with 1 minus sine squared theta. So I can say that my left side is now equal to 1 minus sine squared theta, where I've replaced cos squared theta with 1 minus sine squared theta, minus sine squared theta. Now I have 1 minus sine squared theta minus another sine squared theta, and that's equal to 1 minus 2 sine squared theta, which means that the left side, I've shown that the left side is equal to the right side. So therefore, the left side is equal to the right side. The next identity I'm asked to show is I'm asked to prove that 1 minus cos theta sine theta tan theta is equal to sine squared theta. So again, I'm just going to break this up into the left side and the right side. The left side is 1 minus cos theta sine theta times cotan theta. The right side is just sine squared theta. Whoops. The right side is sine squared theta. Whoops. Okay. So again, the right side is definitely the simpler side, or the side that's written in a more simple form. The left side is more complicated, so I'll just try to simplify it. I know that my final answer has to be written in terms of sine theta, so I'm going to try to replace cotan theta and write it in terms of sine theta and cos theta. So I have 1 minus cos theta sine theta times, I know that cotan theta is, I can rewrite cotan theta as cos theta over sine theta. Now, one of these factors of sine, or a factor of sine theta, divides out here. And what I'm left with is 1 minus cos theta times cos theta. And cos theta times cosine theta is just cos squared theta. So I have 1 minus cos squared theta. Now you might be looking at, how can I make the left side look like be equivalent to the right side? Well, again, using the Pythagorean identity that we had before, if I know that cos squared theta plus sine squared theta is equal to 1, well, then I know that sine squared theta is equal to 1 minus cos squared theta. And I got this just by subtracting cos squared theta from both sides of the equation. So 1 minus cos squared theta is just sine squared theta. And now I've shown that the left side is equal to the right side as required. I'm just going to erase this. It's a good idea not to show your rough work in your answer. Okay, so therefore the left side is equal to the right side, and we have proven this identity. For D, we're asked to prove that cos squared theta plus sine squared theta plus tan squared theta is equal to secant squared theta. So again, on the left side, I have cos squared theta plus sine squared theta plus tan squared theta. On the right side, I have secant squared theta. Now the left side, well, this is right away I can use the Pythagorean identity. So cos squared theta plus sine squared theta is just 1. So the left side is 1 plus tangent squared theta. And now I'm tasked with showing that the left side is equal to the right side. The right side is remember that secant of theta is 1 over cos theta. So secant squared theta, well, that's 1 over cos squared theta. So I'm trying to show that the left side is equal to 1 over cos squared theta. And to do so, I'm just going to convert tan squared theta into, using the quotient identity, I'm going to rewrite tan squared theta as sine squared theta over cos squared theta. And now I have to write this in such a way that I have 1 over cos squared theta. So here I'm going to add these these two terms, or combine these two terms such that they're written over a single denominator. I have to find a common denominator. So I'm going to take 1 and I'm going to rewrite it as cos squared theta over cos squared theta. And so now I have cos squared theta over cos squared theta plus sine squared theta over cos squared theta. And this is equal to, well, now that I've found a common denominator, I can add the numerators. And the numerators are, I've got sine squared theta plus cos squared theta divided by cos squared theta. Now, sine squared theta plus cos squared theta, well, that's just equivalent to 1. So I have 1 over cos squared theta, which is secant squared theta. So I've shown that therefore, the left side is equal to the right side. And I've shown that this identity is true. Okay, so next in E, we're asked to show that sine theta plus cos theta squared is equal to 1 plus 2 sine theta cosine theta. So one of the things that I can do here is if I have sine theta plus cos theta squared, I can try to expand the left side and try to simplify it to be equivalent to the right side. So first off, let's break this down into the left side and the right side. I have that the left side is sine theta plus cos theta squared. The right side is equal to 1 plus 2 sine theta cosine theta. And so now I can expand this. Remember that a common mistake here is to write that this would expand to sine squared theta plus cos squared theta, which is not true, because if you think about it, this is really the same as expanding a binomial. If you have a plus b squared, you'll get a squared plus 2ab plus b squared. And so here, if I square a binomial, I should get 3 terms, not 2 terms. So a common mistake is to write that a plus b squared is equal to a squared plus b squared, which is not true. We get 3 terms. So here, if I expand this, I get that this is equal to sine squared theta plus 2 sine theta cos theta plus cos squared theta. Now, sine squared theta plus cos squared theta is just 1. So I have 1 plus 2 sine theta cos theta. And that's exactly what the right side is equivalent to. So therefore, I've shown that the left side is equal to the right side.